So here's an example. We're going to find all of the roots of x to the third plus 6x squared plus 11x plus 6. And I'm not giving you the first one. Okay? So we're going to do synthetic division, and we're going to try to find numbers where the remainder is 0. Because that's what we did yesterday. Only we knew what number to put in. And so the question is, what should we synthetically divide by? Okay, well, the only help we have is we have a test called the rational root test, or the rational root theorem, that says that the numbers that are going to give you 0 for a remainder are factors of the constant divided by factors of the leading coefficient. If you're going to synthetically divide by something and get 0 as a remainder, it will fit that criteria. It will be a factor of the constant divided by a factor of the leading coefficient. So, here's what I mean by that. The constant in our function is what? 6. And the factors of 6 are 3 and 2 and 1 and 6. Positive and negative. You got to count both. So those are the factors of 6. There are 8 of them. 1, 2, 3, 6. Negative 1, negative 2, negative 3, negative 6. The leading coefficient is 1. And the factors of 1 are plus and minus 1. If the leading coefficient was something other than 1, you would have more than one number on the bottom. Whenever the leading coefficient is just 1, though, you can ignore it and just focus on the top. So, for this particular problem, synthetically dividing by something and get a remainder of 0 is going to come from one of those 8 numbers. So that is where we start guessing. And I'm going to be guessing, I'm going to go back to our chart. Because unless you're, David Blaine street magician, you're not going to be able to guess right the first time every time. Okay, so our factors are 1, 2, 3, and 6, positive and negative, and you can start guessing wherever you want. It doesn't really matter. And it doesn't matter what the remainder is if it's not 0. It's 0 or bust. Okay? So if I put in negative 6, okay, sometimes I start guessing specific ones, but in general, if the numbers are all relatively small, I'll start with the smallest one and work my way up, similar to what I did a couple sections ago with my synthetic division chart. Drop down my 1. Negative 6 times 1 is negative 6 plus 6, 0. Negative 6 times 0 is 0 plus 11, 11. Am I going to get a 0 on that remainder? No chance, so I stop. I don't care what the remainder is if it's not 0. That's how this process is actually fairly quick. Okay, if I'm not talking and you can stop when you know it's not the remainder that you want, the process goes really quickly. Next, I'll do negative 3. Bring down the 1. Negative 3 times 1 is negative 3 plus 6 is 3. Negative 3 times 3 is negative 9 plus 11 is 2. Oh, there we go. Negative 3 times 2 is negative 6 plus 6, 0. Second try, we got one. So what are we going to do with it? Well, we take what's left. Because how many answers do we still have left to find? It's a third degree equation. We found 1. We still have 2 left to go. So we take what's left, which is 1, 3, 2, and we write a quadratic with it. X squared plus 3x plus 2. And we're just going to now solve that, because that's going to give us the other two answers. And you can use the monkey method if you can, or if you can't use the monkey method, you have to use the quadratic formula, which you're going to have to do today, so I hope you know it. This one, though, will factor into x plus 2, x plus 1, giving us roots -2 and -1. Very, very similar to yesterday, only I didn't tell you the first one. You had to guess at it. If you would have guessed one of the other two first, that's fine. Maybe you guessed and got -1 first. You would have got the other two from your monkey method. Doesn't really matter which one of those three you guess first. You're going to get the other two through the factoring. To graph that, we would have zeros at -3, 2, 1. Our end behavior is 1 up, 1 down with a positive slope, just like all of the ones on your homework yesterday. And it's got to go through the red dots. So there's a estimated graph for that function. It's crucial that you see the similarities to yesterday so you are not learning a brand new deal today that we're just adding on to what we already know. Okay. Questions so far? All right, let's try again. F of x equals x cubed minus 3x squared plus 9x plus 13. The factors of 13 are 1 and 13. If, and let me just show you an if the leading coefficient was a 2, here's how that would work. On the bottom, we would have to put the factors of 2. So one of our possible guesses would be 1/2. I would wait till the end of my synthetic division chart to start guessing fractions. I would guess the whole numbers first, but those are possibilities. Okay, 13 halves would be another possibility. -13 halves would be another possibility. Okay, you've got to take every possible number that you can get from that group fraction or whatever you want to call it. But that's not what we have here. I'm just showing you how it would work with a leading coefficient other than 1. All right. Looking at this particular one here, I've got that. And there's my possible guesses. -13 times 1 is -13 plus -3 is -16. Oh my gosh. That's not going to work. Am I going to be able to get back to 0? No chance. No chance. That's like 200 something. There's no chance. -1 times 1 is -1 plus -3 is -4. -1 times -4 is 4 plus 9 is 13. -1 times 13 is -13 plus 13. There we go. One-third of the mystery solved. We take what's left, we take the leftovers, and we put them into a quadratic. And what's our conundrum? How do you get a -4 out of a 13 when you're factoring? You can't. So we're going to have to use the quadratic formula. Okay, so let's talk through the quadratic formula one time, and then I'm going to expect you to know it since we've already talked about it in here. Opposite of b, plus or minus, square root of b squared minus 4ac all over 2a. All right. That mess under the root sign is negative 36, which throws a red flag up to me immediately because I know that that thing is what? Imaginary. Negative 36, the square root of negative 36 is 6i, which we talked about last chapter. And if I check my triangle, like we talked about last chapter, that thing simplifies to 2 plus or minus 3i. All covered last chapter. All will be on your final December 21st and 22nd. So my other two solutions are 2 plus 3i and 2 minus 3i. How many times does this graph hit the x-axis? Alex? Once. And then we have a swing and a miss somewhere to account for our other two imaginaries. Okay? So on your, if you drew a estimated graph, would look something like that, or your swing and miss could be below the x-axis, whatever. My possibilities are the factors of 100, which are 1, 2, 4, 5, 10, 20, 25, 50, and 100. I am going to start guessing at 1. And with 1, it's just not going to work. I can tell. When I start drawing my arrow, that means I know it's not going to get to 0. 2, 26. 4, boom. 4 works. So I take what's left, take the scraps, and I create a cube function from those. So these scraps from my synthetic division transfer down to here, not including the 0. And now I'm dealing with a third degree function. I take my new factors of my constant, 1, 5, and 25. I don't have to check 1 because I already know it doesn't work. So I start with something different. 5 doesn't work. Negative 1 does. So far I have found that 4 works and negative 1 works. So I take the scraps and I make a quadratic out of it. X squared plus 25. Set that equal to 0. Subtract the 25 to the other side. Take the square root. You get 5i. So those two are imaginary. So my answers are 4, negative 1, plus or minus 5i, which means you're going to have a W-looking graph with a swing and a miss somewhere. Real solutions at 4 and negative 1. So there's a possibility. The swing and the miss does not have to be in the middle, however, although that's usually the place where kids put it, but it could also be somewhere like this. Whatever. Okay?